Here we go. So, yesterday it seemed like we learned how to read transformations, which is great. Now, what do we need to know is so that you can work out the equation of a graph by looking at it, or you can sketch a graph by looking at the equation. That's the goal. So today I'm just going to get you to practice that. Remember I said, don't do all the questions. It'll take too long. Be smart about it. Pick a few. Okay, start on 3E. You got it. Move to 3F. 3G, sketch, and then 3H, identify equations. Okay, the only extra thing I need to teach, which will be on Monday, but all I'll be doing is matrices. How do you use matrices and transformations? That's the last part of chapter 3. So if you really think about it, chapter 3 is about understand transformations, sketch, and find equation, and then finally matrix transformation. That's it. Okay, if you really think about it, it's really two sections to it. It's just transformations, and then matrix transformations. There's only really two parts to it. All right, so watch the videos. I just posted it up just now, and if you didn't understand it, rewatch it, try to understand the concept, try to understand the method. So you don't have to do a lot of questions, you just need to understand it, then you can apply. Pick a few questions, and if you can apply it, great. Okay, so here we go. Let's have a look at the exercise 3 if you haven't looked at it. The goal is to look at each of these graphs and then read the transformation. So you could pick out A, and you should be able to read dilation of factor 2 from, and this is affecting your Y, so if it's affecting your Y, it's from the x-axis, up by 3, and then to the right by 1. That's what I want you to be able to do for every one of them. So that means if this is a cubic graph, you see, because they're saying you start off with a cubic graph, x cubed, and you're applying those transformations. So if this is my normal cubic graph, which is poorly drawn, x cubed, and we figured out we can read it, and it says dilation factor 2 from x, so that means I'm affecting my y, makes it thinner. So if I were to draw a new graph, I'm like, okay, so it's thinner, so it's stretched along the y, okay, along the y and away from the x-axis, so it's stretched by a factor of 2, so everything gets doubled. Okay, and then it says up by 3, and to the right by 1. So logically, to the right by 1, up by 3, that means the point of inflection is over here, and you've got that thin shape. That's a rough graph. I don't actually know if it crosses through the center or not. Okay, but what I do know is the point of inflection is at 1, 3, based on that. Okay, and that's what you want to be able to do. You should be able to look at each and every one of these, and then hypothetically figure out, well, what should it look like? Okay, so you can look at a truncus function to the right by 3, down by 2. So that's truncus function. We know that it looks like this with those asymptotes at x equals 0 and y equals 0. So if you can read the transformation, you can move your asymptote. So in our case here, moving the right by 3, it changes the asymptote to x equals 3 instead of 0. And it says down by 2 instead of 0, then my new y asymptote would be at y equals 2. There's no reflection, so the shape stays as it is, and it looks like that. Okay, that's what I'm saying. So if you can read the transformations, you can sketch. But remember, yesterday's session I told you to memorize all 5 graphs that you learnt in year 11. You have your truncus, rectangular hyperbola, you got your exponential, you got your log, you got a square root function, along with all your polynomial functions as well. Okay, like x to the power of third, x to the power of 2/3, and I taught you how to figure that out. If you've forgotten how to do that, revisit that. Okay, because your skills to be able to picture all graphs, there's all your tools, and then transformations just adding to that so you can analyze. Remember, methods is all about analyzing functions. You can't picture it, you're screwed. Okay, domain, range, everything comes from a graph. Application questions depend on a graph. So if you can get the graph, you can see it, you can analyze, you can answer it. Okay, it's when you can't that you get it wrong. Okay, so here we go. This whole sort of first step in this first slide is just me picking out a question, and I've gone through the steps on how I would have found out the transformations and how I knew it was to the right by 1, because x plus 1 means right by 1, and then 2 is a dilation factor of 2 from the x-axis because I'm affecting my y values, and then that's up by 3. Okay, so that's just showing in case you didn't understand from yesterday, you can rewatch it again. watch yesterday's video and then watch today's video so that it makes sense how I can read it without doing all this. Okay? And that's what I want you to be able to do as well. You have to be able to do all this without doing it. Okay, so do it in your head, read the equations. And if you can't read it, do this. Practice this until you pick up a pattern. Then you can just read it the way I do. Okay? All right, now, just to practice, I want you to pick, I'm going to pick a couple of questions here and I want you to roughly sketch it, and I'm going to roughly sketch it afterwards so that you can check if you're doing it correctly as well. Okay? So I'm going to start off with an easy one, A. Let's find, what's another one that students confuse? Maybe F looks confusing. Let's try, I reckon I, and we'll put in H. Roughly sketch. I don't want to find the x-intercept, y-intercept, okay? And just in case you've forgotten each and every one of those curves, I'm just drawing the original graphs. So you've got a square root function, starts at 0, that's a root of x function. The truncus looks like that. Asymptotes at y equals 0, and asymptote at x equals 0. What else is there? And a rectangular hyperbola for you. X equals 0, y equals 0. And that should cover, but you sketch, roughly sketch A, F, H, and I. So you know the original graphs, you're just reading the transformation so you can sketch the graphs. Obviously in year 12 in the exam you are meant to find the intercepts, but intercepts is algebra. I'm not getting you to do algebra right now, I'm just getting you to read transformations. Alright, let's go through some solutions here. A. Name me a transformation that you can see. Can I please have David give me one transformation C from A? Reflection in the x-axis. Good. You're affecting the y value, so it's reflection in the x-axis. Remember Dr. T, so reflection in the x-axis first, and then what's another transformation you can see, Stephen Zhao? 3 to the right. So 3 to the right. You can rearrange that and you'll find that it'll be x dash minus 3 equals x, therefore x equals to x plus 3. Okay, and that's why we know. That's why we know it's to the right by 3. It's all about rearranging, but that's okay. Write 3. Okay, so 3 to the right. And so if I were to sketch this, this is your original graph. Okay, I know it's reflection first, so it should look like this first. Reflection the x-axis, not the y-axis, the x-axis, and then 3 to the right. So that means starting from here now at 3 moves down. Hands up if you got that correct for A. Should move across to the right by 3 and it's down, quadrant 4. Excellent. Next one, B. Let's have a look at B. So B. Name me one transformation. Can I please have Jack? What do you see? Up by, not up by 2. No. This is because all the y's if you do the transformation, you'll find that it actually goes back. So this is actually down by 2. Did I say B? Oh, sorry. F. I meant F. Down by 2. What am I talking about? Down by 2, yes. Down by 2. Name me another transformation for F, not B. F. Rex, give me another one. Two to the left, good. So it's plus 2. If you rearrange that, it becomes minus 2. So it's left by 2. And then give me another transformation, Murray. Good. Reflected in the x-axis, because it's affecting your y value, reflected in x. And then my very last transformation, Layla. Fantastic. So this is affecting your y, so it's dilation of factor 5. Factor 5 from the x-axis, because you're stretching it with the y values. You're stretching it. All the y values increase, so it's away from the x. Okay, so moving away from the x. So that's why we use the word from x. Okay, so what that basically means, it gets thinner, moves to the left by 2, down by 2, and it's reflected in x. So if I had to follow it, reflect in x first, or if you think about dilation first, sorry. I should do this. This is A. Let's do B. B, we know it's dilation, so it should be thinner, it should be stretched out, it should be wider. So it's going to be something like that. Okay, it's going to start out wider, but overall the shape's still going to be a square root function. Down by 2, left by 2. So left by 2, down by 2. So it starts here now. And I've done the reflection. I know that's the reflection, so it goes down like that. There you go. Okay? So that's why if you were to answer both of these, it's easy because once you've figured it out, you can see it in your head. Answering the question, state the range. It's really straightforward. It's negative infinity up to 0, negative infinity up to negative 2. When you read the transformations incorrectly, you get it wrong. And that could be a typical question for your exam. Multiple choice question, A, B, C, or D, and they'll give you an interval, and that's what you have to do. But if you can read the transformation, you don't screw up on that. It's a very easy step. Okay. Next one. Let's read H. Give me a transformation for H. Can I please have Jonathan? Left. Good. This is left by 2. Give me one more, Karen. Reflected in the x-axis. I'm going to use R in x. Okay, and then give me another one. Can I please have Luke? Good. Dilate factor 2 from x. And then one last one. Can I please have Gary? Down by 4. Fantastic. So this is down 4. So if I were to draw the graph, I can say, all right, this is a truncus function because it's squared, its denominator squared. So it's a truncus, so it looks like this. And now I'm going to say it's dilated by a factor of 2 from the x, and that means all these values get thinner in this region here. But remember, after number 1, these get smaller. Because when you're squaring very small values, the denominator gets larger, so therefore it gets smaller. Alright, so what you should see is it should look more like that. But because you don't have anything to compare with, it doesn't really matter. You can just draw that. No one knows. Okay, it's just when you draw a comparison, you have to know the difference between the two. Now, I haven't seen that in exam as often. It's like once every 5-6 years, so probably don't have to worry too much about it, but I still need you to understand it. Okay, so we know it's thinner, and we know the shape is now reflected in x, so actually it looks more like this. Okay, and then it goes down by 4 and left by 2. So down by 4, that means my asymptote now has gone down by 4, so y equals -4, and it's to the left by 2, so that affects my x values, x equals -2. So this is what your graph should look like. Hands up if you got H correct. Fantastic. Hands up, keep it up if you also labeled your asymptotes. Good. You have to always label the asymptotes. Okay, without it, it doesn't make sense. You always have to label the equation. Okay? Do you need to put in one coordinate to show the dilation? Yeah, like the real proper way is that's what you should do. If you don't do it, they won't penalize you. Because it's normally they just say label equation of asymptotes, and they say the 3 marks come from shape, intercepts, and equations your asymptotes. So it's very unlikely that they're going to penalize you for not having a coordinate, because you might have a coordinate when x equals 1, someone else might have when x equals 0, someone might just say when x equals -2, therefore y is undefined. You know, like it's yes and no, unless they say it in the question. Unless they say it in the question, then you do it. But yes, if you want to be very comprehensive and you have the time, yeah, just put in a coordinate to show that you know it's a dilation of factor, whatever it is.
But what if we get the coordinate wrong?
Yes, then you get. See, that's what I'm saying. So if they put a mark for it, they'll take a mark off. But normally they don't. They normally don't give you the mark, because let's say
if you put the wrong coordinate, if they're not marking it for that, then you want to lose a mark.
You should lose a mark. You will lose a mark. So if you put in a corner and you get it wrong, yes.
Then you don't put it down.
Yes, well, that's what I'm saying. You don't need it. Yeah, you don't need it. Okay, next one, last one. Now, just the last one. It's interesting because if we're going to read the transformation, right? Down by 5 is obvious. But the 3 and the 2, you can read it 2 ways here. You can read this as 3 over 2 times 1 on x minus 5. So what that implies is this is a dilation of factor 3 over 2 from the x-axis. So you can say dilation factor 3 over 2 from x-axis. Or you can also read this as 1 over x multiplied to 2 on 3. Okay, so that means that's a dilation of factor 3 over 2 from the y-axis. Okay, because remember, when you rearrange that, if it's 2x, it becomes x over 2. So it's 2 on 3 and it becomes 3 on 2. Yeah? Yes?
If you can do that, can't you say like dilation for G, for example, like say dilation is negative?
G... No, so negative is a reflection. We're talking about values here, so it's either 1.5, 1, twice, 3 times. We want to know how wide is every step. But the negative tells you a direction. This doesn't tell you direction, this just tells you value. So we're either talking about the x values or the y values changing for every 3.5, or we're saying the x values are changing for every 2 1/3. But that doesn't tell you the direction. See, if you put a negative, it tells you now you're doing 2/3 that direction. If you put a positive, it says 2/3 that direction. But the 2/3 is the quantity. That's your dilation. The reflection tells you direction. So are you going positive direction? You're going negative. That's the difference between the two. Yeah. So the negative is just telling you direction. Yeah. Whereas dilation just tells you how much of a step, how big is the step you're taking. Yeah. But in terms of what I'm trying to say here is, regardless of how you describe the transformation, it's the same. Whether you say dilated by factor, because you can even say this, you can still say this is dilation of factor 3 from x, so you're affecting your y values, and you can say this is dilation of factor half from y. Both of them are the same, because half from y just means that you're shrinking the x values. Every x value you're halving, so it's getting thinner, and then factor 3 from x means you're stretching that way. Or, if you think about it, if you times it by 3 over 2 from x, it's 1.5 up. So that means it's still 1.5 this direction. So therefore, if it's 1.5, it's still thin, both of them. Whether you halve the x or you stretch the y, it's still getting thinner. So that's why it doesn't really matter how you say it. It does matter in the exam, so they won't give you something like that. If they were going to give you something like that, they'll be very obvious. It'll be something like this, for example. So they'll say y equals 3 bracket 2x. Yes, you can still rearrange that. You can try to force out that 2, but it takes a lot of effort. So right now, it's easier just to say dilation factor 3 from the x, dilation factor half from y. Okay, that's how they would want it. Otherwise, that's why if you think about your quadratics, you know when you say 4x squared, you see you can see this as either 2x squared, or you can see that as 4 times x squared. So you can read that as dilation factor 4 from the x, it gets thinner, or you can say dilation factor half from the y. And that's why if you actually sketch 4x squared, it's a thinner graph. Like this is your quadratic graph, then 4x squared would be thinner. The only reason why it's thinner is either you're halving all the x or you're multiplying all the y's. It's up to you how you want to see it. And examiners normally won't be doing that because then it takes too much effort to read. Because it isn't like everyone could have a different answer. So normally examiners won't have that. They have a very specific answer. They might talk about sequence, and it's in a particular order that it only has to be this way. There's no 2 answers to it. This one has 2 answers. You can read it as from the x or from the y. It's up to you. Okay? But having said that, it looks like we can read transformations now, so that's good. That's sketching. Now, once you know how to sketch, which, that was it, this is now sequence. And I talked about sequence, you have to use Dr. T in general. Dilation is your multiplication. Reflection is still a multiplication. And then translation is your add, subtract. So BODMAS, yeah? Here, it's regardless of that, you are still going to do it according to the sequence they tell you. Sometimes they say add first, sometimes they say multiply later. Because there's a difference between saying this, 2x plus 1 versus x plus 1 times 2. So that's different. So if I said translation first, then multiply, this is my equation. Technically, if you expand this, this is 2x plus 2. That's different to this. This is saying times it by 2 first, then add 1. This says add 1 first, then times it by 2. So the order does matter. So this is what I'm saying. In the exam, you're likely to get something like this. Less likely to get what I showed you before because the sequence could be whatever. It could be Dr. T. Okay? So in this question here, what I want you to do is you've got y equals x to the power 4. Follow the sequence. Okay, and then I want you to find out what the equation is for me. What's the transformation equation so that I get a reflection in the y, I get a dilation factor 2 from the y-axis, translation of 2 units in the negative direction of the x-axis, and 1 unit in the negative direction of the y-axis. I want you to find out the equation for me, then I'll give you the answers. Okay? Let's have a go. You see, I'm just revising what we did yesterday. You understand transformation? You can figure it out. So write out your coordinates. How I would start it is this concept. What is my transformation? What do I want? Okay, that's what you're trying to find. Because once you find this, you can rearrange it. Sub it back into the original and you get your answer. Yeah? This is what you want. When you said reflection and y-axis, what is that affecting? Is it my x or is it my y? When I say dilation of factor 2 from the y-axis, what am I affecting? Is it my x or my y? And then translation 2 units negative, the x, 1. Because you get this one correct, then your equation will be correct. You get this one wrong, then the equation will be wrong. Obviously, as you get faster at these, you won't ever have to do these steps anymore. You can just directly play with the equation itself. But just to start off, it helps to do that. All right, here we go. Let's write each step. Reflection and y-axis. If it's reflecting the y, it has to affect your x, so it's negative of x. That's the first step. Next one says dilation of factor 2 from the y-axis. So if you're moving away from, you're doing horizontally. So that means you're affecting your x again, and you're timesing that by 2. So it should look like this. Double all your x values, and it's all reflected already. Okay, so times it all by 2. Next one, translate 2 units in the negative direction of x just means minus 2. So x minus 2, so that means left by 2. Whereas this one says 1 unit in the negative direction of the y, so that means down by 1. Okay, negative is in the down, it's down because it's in the y-axis. So, here we go. You should have got negative 2x minus 2. That's reflection in the y. Factor of 2 from the y, from the x, or from the y, sorry. And then left by 2 and down by 1. Okay? Hands up if you got that correct, just the transformations, because you need that first. If you get that wrong, everything goes wrong. You get that right, then now here's the next step. You can either do this and rearrange it, or you can have just affected that. Okay, it's just that most students will make a mistake with the dilation. That's why I'm taking the steps out. That's your new x value, so x dash equals to this, y dash equals to that. Rearrange it, and that's the one that most students make a mistake here. They forget that it's actually a dilation of half. And if they split that up, that's minus 1. Okay, so if you rewrite that, and I put it all in, you can simplify this. And that should be negative x dash on 2 minus 1 to the power of 4 minus 1. Okay, because that could be in your multiple choice question, and you might get that, but the actual answer is that. Okay, so it's both the same thing, because that you're actually, even though we're saying move across by 2, but because you're saying there's a dilation there, it looks as if you're not moving it to the 1. You're actually moving it twice. Okay, so you're moving it 2 times. But having said that, hands up if you got this answer. Or either answer. Wait, did anyone get up to this step at least?
I think the 2 out, like I make the 2 on like 16. and then x plus 2, like 16 is the denominator.
Oh. So you thought you made this to the power of 4, and then you took that out.
I didn't take that. It's still denominator.
So you took out that value. So what I'm understanding is you wrote x dash plus 2 over 1 negative 2 4. So it'll be 1 on 16 x plus 2 4 minus 1. Yeah, it's fine. It's just, that's a different, in terms of reading it, it's different. Like, remember how I said reading it, you can read it in any way. Technically, that now is a 1 on 16 dilation, factor of 1 on 16 from your x-axis. But hey, the equation's right. Like if you type this equation and type this equation into your calculator, they both sketch the same graph. So it doesn't really matter. This one looks nicer though. Yeah, it's much nicer than the one I have. Okay. All right, excellent. So that's question 5. Question 6, same drill. It says find the sequence now. So you're going backwards. So this is yesterday's session. Try to find me the backwards now. So I've got, you can either read it from there or you can do the backward step to get the answer. But I want you to have a go with this one. Read, because once you can read, the last one is exercise 3H. Because what I'm doing is I'm going through 3F, 3G, and now I'm going to 3H afterwards. Okay? But what I'm trying to show you is chapter 3, even though I said I'm expressing through it, you see it's only one concept. You're only learning transformations. Okay, so that's the bulk of it, and the next part is matrix transformations. But you have to understand what transformation is first. Okay? Have a go with this one. Well, you can probably read it already. Tell me. But because it says find a sequence, it now matters what comes first and what comes next. Okay, so just be careful with the order. Dr. T in our case here. It matters. So it's always Dr. T, dilation, reflection, translation. Remember, you don't have to do it this way, it's just in case you haven't practiced well enough yet. I'm just showing you how the steps are. From here you can read your transformations, clearly left by 1, reflected in your x, factor of 3 from your y, up from your x, and then up by 5. Yeah? So your sequence, remember sequence Dr. T, it's always times first, then your translation afterwards. So your sequence should be dilation of factor 3 from the x, reflection in the x, and then translation of 1 unit in the negative direction. It doesn't matter which one. Normally you write it all in one line. So you say translation 1 unit in the negative direction of the x-axis and positive 5 units in the y direction or y-axis. Okay? Hands up if you got that order correct. Oh. What happened? Where did we go wrong then? Or where did I go wrong? Did I go wrong? Dilation, got that right.
Does it matter whether you use dilation or reflections?
Logically, no. Yeah. Logically, no. Like you're timesing by -1 or you're timesing. It's just because you say negative and then one, -1, -2, -3. So the 3 had to come first. That's the reason why. Because say times negative, but you have to times -1. So -1, and that value is your dilation. It's a factor. So we want it. Is it a factor 1, factor 2, factor 3?
Can we say reflection first?
Yeah, but then what do you times it by?
You say reflection first, and then you say dilation.
So, but what I'm trying to say is, you know how you go from here? So you said make a reflection first, right? How do you make y to a -1? You can't just put a negative in it. Obviously times it by a -1. And that 1 is a factor. You know what I mean? See, you don't just like chuck a negative.
But what if there is no dilation?
What if there's no dilation? Yeah, then the value is 1. So we're saying it's times by 1, by -1.
The first thing would be reflection of the x-axis anyway.
Yes, the dilation factor of 1. But I get what you mean. Like I know what you mean. It's just really because we're timesing it. Because we're timesing it, it feels like there's no difference. I get you. Does it matter? I don't know. I don't know if I want to risk it. I'll just normally do dilation, reflection. Yeah. All right, here we go. Last question. So, what you've done with me is 3F, sketching, 3G, identifying your transformations either backwards or forwards. 3H is once you can read transformations, that means you can look at a graph and read the transformations from that. Therefore, you know how to solve what the equation should be. That's 3H. Technically, they're all the same one skill, just reading transformations, graph and equation. Yeah? So let's have a look at this graph here. What type of graph is this? What kind of graph do I have here? A what? Yeah, rectangular hyperbola. So, rectangular hyperbola would have to be of the form 1 and x, which normally, it would have started right there. So if you think about it, it would have looked like this. Now obviously, it's changed. The asymptotes have changed. It used to be at x equals 0 and y equals 0. Now I have x equals 1 and y equals 2. What does the y equals 2 imply to me? How do I get my asymptote to y equals 2? What do you have to do? What's the transformation? Up to. Okay, so we know this is up to because you're affecting your y values and affecting your x. X is now right by 1. So hopefully by now you can read your transformation. You can say, oh, well, the only way for that to happen is if it's x minus 1, that moves it to the right by 1. To move it up by 2, it's plus 2. So already I can already say capital B has to be 2, little b has to be -1. So how do you think I'm going to find A? Sub in a coordinate. Okay, you got your y and x values. So y equals 2, and you've got a coordinate. And it said 0, 1. So you can say when x is 0, y is 1. So you got A on -1 plus 2. Therefore, negative A equals 2. 1 minus 2 is -1. Therefore, A equals 1. Okay? So what you can see is I'm not teaching you anything new. I'm just getting you to apply what you understood about transformations and you read from a graph to the equation. Because you can now read from an equation to a graph. And working backwards is graph to an equation. Yeah? Try the next one. And that's the last question. That's 3F, 3G, 3H, 4 matrices. Just quickly read it. You don't have to do anything, you just read it. Write down an equation. Let's see if you know what the answer has to be. You can check the answer. That's from 3H, question 6. You can check your answers. But like I said, I'm whipping through it, chapter 3, but I'm really teaching you one concept. Okay, I don't want you to see it in segments. They all build a picture. It's just a skill. Okay, it's just one skill, transformations. And on Monday, if you like, read ahead over the weekend. It's just matrix transformation you understand these stuff, matrix makes it easy. Okay. And that concludes chapter 3, and I think we would have caught up, fairly caught up. I think most classes are now on 3I or J, which is where we're up to by Monday. It's really good.
-1 to -2 difference, right? It usually goes to
Solve for A by substance coordinate. Other than that, thank you. You guys did well for transformations. And I'll pass on a test probably on Monday as well. Thank you.
Yeah, there's different
Well done. Well done.
Is that right? It's A2.
You should be. Wait, that's.
But did you think of that?
Yeah. Isn't A equal to 8? Isn't it? Unless I did my maths wrong. Because like you bring the 3 across, 3 minus 1 is 2, and then times 4